Good day, dear students. Today I have a plan to finish chapter 2. By the way, I'll start by the last thing that remains, which is neutralization. Many times we have heard something about neutralization in terms of acid and bases. Okay? So let's make it simple. Let's define simply what is neutralization. Neutralization we have studied by starting of this chapter during studying of the properties of acid and bases. What is neutralization? Hopefully you remember what was neutralization. Neutralization, in my expectation, actually you have forget it, but now I'll remind you what is neutralization. Neutralization, it means neutralizing two things that are totally different from each other. Okay? Neutralization, for that purpose we have acid and base, which are totally they are in reverse case. Okay. Neutralization is the reaction of hydronium ion and hydroxide ion to form water molecule. Well, maybe after reading this definition you don't understand a word. So let me open a new page and I'll start by my special way. Okay. Suppose that we have a reaction between two electrolytes. One of them is acid and one of them is base. For example, we have HCl. Okay. Here we have HCl plus NaOH to producing NaCl plus H2O. Okay. This is acid-base reaction, mister. Okay, this is true. It's acid-base reaction. But we have used a special expression for this reaction called neutralization reaction. So this is neutralization reaction. So what is neutralization reaction? It's the reaction between acid and base to producing salt and water. So from now on you have to be aware about the products by a neutralization reaction. We're going to get two products always. One of them is ionic, which is salt. So acid plus base to producing salt and water. Okay, let's take a look. Acid provides H3O. Base provides OH. Okay, look, salt is ionic compound. Water is molecular compound. Okay, so name of that product. Name that product that always yield, that always produced from the neutralization reaction. Okay, can you be more specific with the question? I mean, can you give more detail about the equation? Okay, look, the equation is acid and base to producing salt and water. One of them, one of the products is ionic compound and another is molecular compound. So the products of acid-base reaction, neutralization reaction must be two things always. One of them is ionic compound called salt. And the other is molecular compound, which is water, H2O. So what is that molecular compound that can be produced by neutralization reaction? Okay, it's water. What's that ionic compound that produced by neutralization reaction? It's salt. Well, and now, why we call this reaction neutralization reaction? Because inside of neutralization reaction, there is neutralization. When hydronium ion reacts with hydroxide ion, they produce two water molecules. So this is neutralization. Neutralization. Okay. So this is neutralization, and this is neutralization reaction. So what's the difference between neutralization and neutralization reaction? Okay, the reaction one is it contains acid and base to producing salt and water, but only neutralization is hydronium plus hydroxide to producing water molecule. Well, during this reaction, you have to keep the ratio 1:1:2 always, please. If you get the larger number, the bigger number, you have to make division by a number to get 1:1:2, always. For example, if you have 2H3O plus 2 hydroxide molecules to producing 4 water molecules. So we are looking for the coefficients in this way. So just dividing by 2, you'll get the above one. Okay? So it will decrease. It will decrease it. It will decrease it. So all of them divide by 2. I mean the coefficients. You will get the exact above copy. Okay. Now let's get back to the main point. Neutralization. Okay. Now I think you have idea about neutralization. What is neutralization? Neutralization is the reaction between hydronium ion and hydroxide ion to producing water molecule, which is molecular compound. Salt, the ionic compound 1. Okay, salt is ionic compound composed of cation from a base and anion from an acid. Okay, I prefer to talk about salt in detail. Okay, let's see. Look, actually there are 2 ways to get salt as a product. One of them, acid plus base. Next, metal plus acid. But because of we are living in neutralization medium, so forget about metal and acid until it's suitable time. So for now we are going to concern of those salts that produced by neutralization reaction. So we can say the cation came from the base and the anion came from the acid. So salt is an ionic compound that produced from cation came from the base, anion from the acid. Okay. Look, sodium acetate is a salt. Okay, it's not acid, it's not base, it's salt. So just identify the negative part and the positive part. This is negative part, it's positive part. So just add H plus to the negative part. How many negative percent you have to add that much amount of H plus. For example, if it's -1, you have to add 1 hydrogen, -2, 2 hydrogen, -3, 3 hydrogens. Okay, but here we have +1, so you have to add 1 OH, +2, 2 OHs, etc. So as you know, you have to know that after adding H plus to the acetate anion, it will occupy the end of the ion. Okay, ionic formula. Look, let's see. We just add H to here. Okay, look, it contains CH3, COO negative, Na plus. So just add OH to the positive part, H to the negative part. Okay, so it's weak acid, it's strong acid. Another example, we have ammonium acetate. Well, okay, it contains NH4 plus CH3 COO negative. Okay, let's see. You have to add positive to the negative part, which is anion, to get the acid molecule, and you have to add OH to the positive part to get base molecule, to get a base. Okay, look, cation from a base. After adding positive, after adding OH, okay, just add OH to the positive part, you're gonna get the base, the original. And after adding H plus to the negative part, you're gonna get the acid molecule that provides hydronium ion during producing this salt. Well, just feel free to try this, okay? Just identify negative part and positive part, and then hopefully you remember. We have two things, hydroxide and hydrogen ion, okay? After identifying the negative part and the positive part, just add OH to the positive part and H plus to the negative part. Look, here we have chloride, which is -1. So it needs only one hydrogen to get the acid molecule that previously provided that proton to producing the salt. And now here we have Na plus, Na we know that, sodium cation, it holds +1, so you have to add one OH to get the base. Okay? I think it's quite easy to understand about, and please try to do this for the following examples. Okay, I write some homeworks for you. Just do it for the following things. For example, Na3PO4. Okay, another one. Ca3PO4 by 2. Okay, just identify the acid and the base that they reacted during neutralization reaction to producing the following salts. Okay, another one. Okay, just let me think about it. Well, CaCl2 is a wonderful example, and most importantly is this, barium sulfate. Okay, just identify the acids and the bases for the following salts. Well, maybe you have a question why we are doing this. But be sure that it's a super useful during solving examples. Let's see. Okay. Now you know neutralization is a reaction when acid and base are reacting together to producing water and salt. Water is molecular compound, salt is ionic compound. Okay? Through this form is, you can use it as a rule, but I think you don't need because of you have learned it even in grade 10 and 11. And lastly, in grade 12, we are going to kill it because of, I'm going to mention 100 times, more than 100 times. Okay. For what we are studying neutralization reaction, actually we have many things that we've learned in chapter 1 in terms of spectator ions, net ionic equation, the overall ionic equation. We are going to do the same here, okay? We're going to do them here also. In the same formula, nothing changed. Okay, let's see. Look, we have the following examples, and then we're going to identify the net ionic equation and the spectators, the overall ionic equation. Okay, here. Aqueous solution of HCl and NaOH are mixed together in chemically equivalent quantity, amount, okay? Write the following points. The first one, formula equation of the reaction. Formula equation of the reaction. Okay, I forgot to delete this, but well, I'm going to do from the starting point again, okay? This correct, but I'm going to show you how to write the reaction. Well, if we mix HCl and AOH, so let me tell you something. There are two types of questions here. The first type, you may get the formula of acid and base, just plus them together, mix them together, and write the products. The second type of a question, you may have only a salt, then you have to take out the acid and the base, then again make a reaction between them, to see the products. Okay, but here we have the formula of acid and the base. For example, we have HCl plus NaOH. Okay, the formula of acid and base are known. Fortunately, okay, if they reacted together, we knew that OH, look, knew that H plus OH, they produce H2O. So here we have H2O as a first product. So predicting the products is one of the, actually I can say is a major step, okay? Major step. Then there are cation and anion. If we combine them together, if we make assembly between them to get a salt, NaCl. Okay. Then after this is formula equation. Okay, this formula equation. Well, just I want to clean up the messing Oh my God. No, I regret. Okay, good. Well, and then after writing the formula equation, well, I will write from the starting, sorry. Cleaning, okay. Look. HCl. HCl plus NaOH to producing NaCl plus H2O. Okay. And then you have to balance to keep the total mass at both sides. Okay. The products must be soluble to release the ions to make exchange between them. NaCl is soluble. H2O is liquid. It's liquid. Then, overall ionic equation. Well, hopefully you remember during this step, we concerned the water-soluble compounds to break down the bonds to producing negative and positive ions. Okay. It releases H3O. Okay. Actually, it releases H+. But we know H cannot stay freely, so immediately it will combine with water. It attacks water molecule to producing H3O. So how many H+ present? You have to write the same number of hydrogen ion. 1H, 1H3O, 2H, 2H3O, 3, 3, 4, 4. Okay, etc. I'll show you because of now we are messing with the balance. Okay, because of using water molecule can convert H+ to H3O. So you know now there's imbalance. Okay. Plus Cl. And these are aqueous. It's aqueous plus. Okay. Na plus OH negative. Aqueous. Aqueous. Remember, here we have some points you have to be aware. Look, the number of hydrogen ion must be equal to the number of hydroxide. 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5. Okay? If you have them in different number, that means you just made a mistake in some steps, mainly imbalancing. Okay. Now let's go to the product. Na plus Cl negative, aqueous plus. The only exception that didn't accept to be break is water, so we rewrite as it is. Okay, in the same way that is that's present. Okay, so look, but what will happen to the number of molecules? One hydroxide plus one hydronium plus one hydroxide yields 2. If we have 2H3O plus 2OH, 2 plus 2, 4. If we have 3OH, 3H3O molecule plus 3OH, 3 plus 3 to get 6. But now we have 1 by 1, so they yield 2H2O molecule. Okay? So it's L. And now we are finished with the overall ionic equation. Next step, net ionic equation. Okay? Net ionic equation. Look, actually, it's not conditional to get neutralization always as a net ionic equation because of we have some different question that didn't accept this, but now it's correct. Well, before writing net ionic equation, we have to look for the spectator. The spectators here before reaction and here after reaction. So the spectators are the ions that have same formula, same form before and after the reaction. Look, Cl negative. Cl negative is the first spectator, Na the second spectator. So Cl negative, Na positive are the spectators. So after eliminating the spectators, what left is the net ionic equation, which is H3O plus OH to get 2 water molecules. Aqueous, aqueous, L. Mister, but we have studied this as a neutralization reaction. Yeah, so that's the point. I was looking for this note. Okay, during the neutralization reaction, if we get soluble salt during the neutralization reaction, just write this so carefully. During neutralization reaction, if we get a soluble salt, okay, the negative and positive part of the salt, they become spectator. Na and Cl are spectators. And neutralization will be net ionic equation. Pretty cool, right? Another one. Okay, a second form of a question, look, if we have this salt as a product of neutralization reaction, so write the neutralization reaction, then overall a net ionic equation as well as spectator ions. Well, Ca, look, CaNO3, okay. CaNO3 by 2. Well, we know NO3 is -1. It came from HNO3. Okay, and Ca, it's +1. Ca is +2. Came from CaOH by 2. So now we have a reaction between CaOH by 2 and HNO3. Okay, just like this. HNO3 plus CaOH by 2 to producing CaNO3 by 2, the salt by itself, and 2 water molecules after being balanced. Well, then make your prediction of the solubility in water. It must be water soluble. Water soluble. So, okay, it's water soluble. It's possible to have this water insoluble. It's L. Okay. Then, overall ionic equation. Now I think you remember what is overall ionic equation. Okay, we have 2H, so just write 2H3O. Aqueous plus 2NO3. Wait, mister, please stop. Okay, what? We have 2H3O, so we must have 2OH at the same time. Look, let's start the second compound, Ca plus 2 aqueous plus 2OH, yeah. Okay, correct. So 2H3O, 2OH. Okay, we are in the right way still. Well, let's go to the after reaction. After reaction, we have Ca plus 2 aqueous plus 2NO3 aqueous. Okay, plus 2 plus 2 will be 4. So we have 4 water molecules, L. Okay, and now let's take a look for the spectators. Well, because of the salt is aqueous, so negative and positive parts of the salt are spectator. So that means Ca plus 2 and NO3 -1. Okay, as we can see, NO3, same form. Ca plus 2, same form. So these are spectators. After eliminating the spectators, after they being eliminated, so what left is net ionic equation. So we're gonna get 2H3O aqueous plus 2OH. Well, all right, because we have enough space, so okay. 2H3O plus aqueous plus 2OH negative aqueous to producing 4 water molecules. But you know, I said you have to keep the ratio of the reaction participants by 1, 1, 2. So just divide by 2 to get this. H3O plus OH negative to producing 2 water molecules. Aqueous, aqueous. You know how it's easy? So that was neutralization. Nothing at all. Another one. Another example. Well, I'm looking for the one that is water insoluble. Okay. The one that is water insoluble. Oh my God. Don't know what happened to the screen. The screen gets crazy. Please. Okay. Good. I'm looking for the one that's water insoluble. Actually, I prepared this one. It's very good. Okay. It's water insoluble. Well, let's see. Okay. During a neutralization reaction, if you have BaSO4 as a product, write that neutralization reaction, then identify the spectators and net ionic equation. Well, look, we have BaSO4. It's a wonderful example. So SO4 came from H2. Well, the tip is not sophisticated. So look, H2SO4. Here we have BaOH by 2. So during the neutralization reaction between BaOH by 2 and H2SO4, we're going to get BaSO4. Okay, let's complete the reaction to get BaSO4 plus H2O or H2O. Okay? And now balance. Just to balancing this reaction, simply add coefficient 2 here, then it's water soluble, water insoluble. This is L. Did you remember sulfates, compound sulfate containing are water soluble mostly, except of the one that came with Sirke Hadi, Bapir, Ba, Bapir. So it's insoluble. And now this is neutralization reaction, answer of the first point. The second point, overall ionic equation. So just convert them into overall ionic equation to get Ba plus 2 plus 2OH negative plus, we have 2 hydroxides, so it must contain 2 hydroniums. Yeah, here we have 2H, so it's 2H3O plus SO4, negative 2. Okay, these are aqueous. Aqueous. Then the product, it's salt. So forget about it to be a part. Write as it is. BaSO4S plus 2H2O. No, mister, you just made a mistake. It's not 2H2O because you have told me that you just sum the numbers, the coefficients of hydroxide and hydronium. 2 plus 2 will be 4. Okay. It's 4. Good. Okay. I understand, please. It's 4. I understand, my dear students. You are looking so concentratedly. So 4H2O. Very well. Congratulate. Okay. Clap. Well, net ionic equation, because of you have to add spectators, then take out net ionic equation. Well, Ba aqueous S, no. OH, R3, forget about them. SO4 aqueous S, no. So, mister, there's no participant to be changed. Okay, there's no changed particles. There's no changed member in this reaction. So forget about the spectators. Now there is no spectators. So there is no spec. If we have no spectators, so it's overall ionic equation. You have to say overall ionic equation is equal to net ionic equation. Oh, mister. So during the neutralization reaction, if the salt is soluble, positive part and negative part are spectators, and neutralization is net ionic equation. But what if we have a solid one, so there's no spectator, overall ion equals to the net ionic equation. So it's very important. We have seen this question more than 3 times during last 5 years of the examinations. We have seen this one more than 3 times. So it's very important. Please be aware about this. Okay, and now let's go further. We have to go further. Now the second part is come, which is metal plus acid. Active metal, if reacted with acid, they produce salt plus H2 gas. Okay, let me show you some examples here. We have some wonderful examples here. Suppose that we have Na plus HBr. Okay, just release all the hydrogens to producing H2. Okay, don't care about number of hydrogens here. You have to add H2 here because of writing hydrogen alone as a part of reaction must be in diatomic molecule. Well, now there is only bromide anion here with sodium, so it will be NaBr. Another one, we have Na. Okay. No Na, please change to the another one. Zn plus H3PO4. Well, just remove all the hydrogens to producing H2. Now what left? Zn, which is zinc, plus PO4. It will be Zn3PO4 by 2 plus. Why Zn3PO4 by 2? Because of PO4 is negative 3. Zn produces positively charged 2 cation. Well, okay, let's solve something. This one. Look, Zn plus HCl. Well, Zn plus HCl to producing, well, remove all the hydrogens, H2 plus ZnCl2. Good. Okay, ZnCl2. Well, then make your prediction of this solubility. Well, this is not compound, so it's S. It's aqueous. It's water-soluble, aqueous, it's gas. Well, now convert to the overall ionic equation. S must be right as it is. ZnS plus H must be converted to H. Okay. Wait, mister. You did not balance the reaction, so make a balance, please. Sorry, even me, if I be in a hurry, so you know, even it's possible for me to have a mistake. So we have to be patient. 2 hydrogens, ZnCl2. Now it's balance. Okay, Zn as it is, S plus 2 hydronium ions. 2H3O, aqueous, plus 2 chlorides, aqueous, to producing Zn plus 2, aqueous, plus 2 chlorides, negative, aqueous, plus H2, gas. Look, we have two hydronium ions. There is no hydroxide, so add same number of hydronium ion by water. So there will be two water molecules. Okay. There will be two water molecules, which is L. If you have two hydroxides, you have to sum them together. Okay. Well, now let's identify the spectator. Zn, it's S, it's aqueous. No, forget about Zn. H3O, no. Cl, yeah, Cl. So, the first spectator. So, for the reaction that contains active metal and acid to producing water-soluble salt, there will be only one spectator, which is negative part of the salt or the negative part of the acid. So now the only spectator is Cl. There's one spectator. The rest will be net ionic equation, which is ZnS plus 2H3O aqueous to producing Zn aqueous, okay, plus 2 plus H2 gas plus 2 water molecules. This is net ionic equation. Very easy. Another example that contains water insoluble. Well, I prefer to write one example by myself. If we have a reaction between barium and sulfuric acid, well, they produce H2 and BaSO4. H2 gas. It's solid, it's aqueous, it's solid. Okay. And now it's balanced by itself. The reaction is balanced by itself. Then convert to the overall ionic equation. Overall ionic equation. Okay. Well, doesn't need to write like this. I will write totally. Look. Overall ionic equation. Okay. BaS, right as it is, plus 2 hydronium ions, plus sulfate, negative 2, aqueous, to producing its salt right as it is, plus H2 gas. Look, we have 2 hydronium ions, so just add 2 water molecules. Okay, very easy. And now just look for, we are looking for the spectators. Okay, BaS, but here is in salt. No, it's not spectator. Hydronium, forget about hydronium. SO4, no, so there's no spectator. There is no spectator. So overall ionic equation equal to net ionic equation. So now I'll give you more detail as a summary. Look, if we have acid plus base to producing salt plus water molecule. Well, look, if salt is aqueous, so negative part, negative and positive part of salt are spectators. Neutralization equals to net ionic equation. Neutralization, we know it's H3O aqueous plus OH negative aqueous to producing two water molecules. But now what if the salt is S? So there will be no spec. So what will happen to the net and overall ionic equation? Overall ionic equation equals to net ionic equation. Okay? So that's all about the neutralization. Take this medicine 3 times per day. Well, it's very easy, I think. It's a wonderful summary of the neutralization reaction between acid and base. And what if we have metal plus acid? Okay, to producing salt plus H2 gas. It's possible to have salt as an aqueous, so then negative part of salt or acid will be spectator, and the rest will be net ionic equation. But if the salt is S, so there will be no spec, and overall equals to net. That was the last thing about chapter 2. Hopefully you understand about it very well, and feel free to make your revision of my video and write every point in your wonderful notebook. Inshallah, you're gonna get the highest mark that you want. Again, I'll tell you, please be careful about the formulas of the acid and the base, how to write the formula of the salt, and how to return back the acid and the base from the salt's formula. Inshallah, لو أنا دهاتو دست دکیم به چاپتری سیم تا وقت به خواتن دست پیرم هر شاید و سرفراز من خواتن لگەڵ.
بیرنامێنەی لەوەی خوێندوویانە. هەندێک لاپەڕەیەکیان خوێندووە و چوونە سەر لاپەڕەی داهاتوو لاپەڕەی پێشوویان بیر دەچێتەوە. هەندێکی تر پەرەگرافێکیان خوێندووە چوونە سەر پەرەگرافی داهاتوو ئەوەی پێشوویان بیرنامێنێت.